Dear children, let us continue the chapter Quadrilateral. Now let us continue the exercise 1 of that chapter, the 9th question. In a parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP equals BQ. Show that first one, triangle APD is congruent to triangle CQB. Second, AP equals CQ. Third, triangle AQB is congruent to triangle CPD. Fourth, AQ equals CP. Fifth, APCQ is a parallelogram. Here we have to prove these 5. Now what is given here? It is given that ABCD is a parallelogram, and also on a diagonal BD, 2 points are taken in such a way that DP equals BQ. Now let us prove one by one. So you write solution. What is given here? Given ABCD is parallelogram. Given ABCD is a parallelogram and P and Q are lie on BD. P and Q are lie on BD such that DP equals BQ. DP equals BQ. Now to prove the first one, what you have to prove? Triangle APD is congruent to triangle CQB. So you take to prove triangle APD is congruent to triangle CQB. Now to prove that, write the names of the two triangles. So let us prove by taking the two triangles. In triangle APD and triangle CQB. It is given that DP equals BQ. You write DP equals PQ. DP equals BQ. That is given. What is the reason? Given. Here we have taken the triangle APD and triangle CQB, and here DP equals PQ. That is given. Next, you know that the opposite sides of a parallelogram equals. So you write AD equals BC. That is also given here. That is opposite sides of a parallelogram. Right? AD equals BC. Reason you can write here opposite sides of a parallelogram. Opposite sides of a parallelogram. You got two sides. Next you take the angle. Here angle ADP must be equals to angle QBC. Angle ADP must be equals to angle QBC. What is the reason here? You know that they are the alternate angles made by the transversal BD of AD parallel to BC. In parallelogram, opposite sides are parallel, that you know. Here AD parallel to BC and BD is a transversal. So these two angles, angle ADP and angle QBC, are the alternate angles, interior alternate angles are made by the transversal BD of the parallel lines AD parallel to BC. So you write alternate interior angles or alternate angles made by the transversal PD of AD parallel to BC. AD parallel to BC, as ABCD is a parallelogram. So you can write, here you got the side angle here, these two sides and include angle. These two sides and include angle are equal here. So according to SAS congruence rule, you can write that triangle APD is congruent to triangle CQB. Therefore you write, therefore triangle APD is congruent to triangle CQB according to which congruence rule? SAS congruence rule. SAS congruence rule. So you proved the first one. What is that? This is the first one. Here triangle APD is congruent to triangle CQB. You proved this. The second one, what you have to prove? AP equals CQ. You know that AP and CQ. In the figure you can observe here, AP and CQ are the corresponding sides of congruent triangle APD and CQB. So here to prove AP equals CQ, here you can say as triangle APD. We proved that, you write, we proved that triangle APD is congruent to triangle CQB. Therefore you can write AP is equals to CQ. AP is equals to CQ according to CPCT. According to CPCT, you got the second one. Next what you have to prove? We have to prove that triangle AQB is congruent to triangle CPD. Triangle AQB is congruent to triangle CPD. To prove third one, to prove triangle, so you write to prove triangle AQB congruent to triangle CPD. Here again you have the figure here. You know that the triangle AQB is here and triangle CPD is here. We have to prove that they are congruent, and as usual here from the first proof we can prove this triangle AQB is congruent to triangle CPD. You write the names of the two triangle. In triangle AQB and triangle CPD, in triangle AQB and triangle CQB, here it is given that BQ equals PD. So you write BQ equals DP. PQ equals DP. That is given. That is already taken for the previous proof. BQ equals DP. And also you can write AB is equals to DC. AB is equals to DC. Why? AB is equals to CD. The same reason, they are the opposite sides of parallelogram. Opposite sides of a parallelogram. Opposite sides of a parallelogram. And also you can take angle ABQ equals angle CDP. So you write angle ABQ equals angle PDC or CDP, angle CDP. Same reason, they are the alternate angles made by the transversal of BD of parallel line AB and CD. They are the opposite sides of the parallelogram. So you write the reason alternate angles made by the transversal BD of AB parallel to DC. AB parallel to DC. Now according to the SA's congruence rule, you can write that triangle AQB is congruent to triangle CPD. Therefore you write, therefore triangle AQB is congruent to triangle CPD. Same congruence rule, that is SAS congruence rule. SAS congruence rule. Here you proved third one. Next we have to prove that AQ equals CP. You know that as you proved triangle AQB is congruent to triangle CPD, AQ and CP are the corresponding sides of these two triangles. Directly you can write AQ equals CP. So you write the fourth one to prove, here fourth one to prove AQ equals CP. AQ equals CP. So we proved that what? We proved that triangle AQB is congruent to triangle CPD. Here we proved triangle AQB is congruent to triangle CPD. Therefore you can write, therefore AQ equals CP according to CPCT. You can write according to CPCT. They are the corresponding parts of congruent triangle. They are the corresponding sides of the congruent triangle AQB and triangle CPD. The next fourth one, what we have to prove? We have to prove that APCQ is a parallelogram. What we have to prove? APCQ. Here the quadrilateral APCQ is there. We have to prove that that is a parallelogram. So you take the fifth one to prove APCQ is a parallelogram. Once again have the same figure here. Here APCQ is a quadrilateral. We have to prove that that is a parallelogram, and when it becomes parallelogram, you know that if opposite sides are equal and parallel, then it becomes parallelogram. To prove that opposite sides are parallel, here you know that if alternate angles made by the transversal of two lines are equal, then that two lines are parallel. So you take these two triangles are congruent. If you prove that two triangles are congruent, then the corresponding angles becomes equals. So you can show that the angle APQ equals angle PQC, and then you will get AP parallel to QC, and also you will get angle AQP is equals to angle QPC, As they are alternate angles and they are equal means thus AQ becomes parallel to PC. As you got the opposite sides are parallel, then you can conclude that APQC is a parallelogram. So let us write the proof here. So you name the triangles APQ and triangle PCQ. In triangle APQ and triangle PCQ. In triangle APQ and triangle PCQ, you write AQ equals PC. Why AQ equals PC? It is proved here. AQ equals PC is proved. Here only you will get. As these two triangles are congruent, we proved that AQ equals PC, and also we proved here AP is also equals to QC. AP is also equals to QC. That is also proved by taking these two triangles. Triangle BQC and triangle APD, we have proved that. Therefore, the two triangles becomes congruent here. So you write first one AQ equals CP. AQ equals CP. Here AQ equals CP. That is proved. Where you got it? From fourth here. Proved in 4. And also AP equals CQ. AP equals CQ. That is also proved in true. Proved in second. And also you can say that here common part is there, that is PQ. PQ is a side of both the triangle. You can write PQ equals PQ, that is common. PQ equals PQ, common. Therefore, you can write that triangle APQ is congruent to triangle PCQ. According to which congruence rule? SSS congruence rule. SSS congruence rule. SSS congruence rule. Once you got that they are congruent means their corresponding parts are equal, therefore corresponding angles are equal, and also corresponding sides are equal. Here you can write that angle APQ equals angle PQC. Angle APQ equals angle PQC. So you write therefore angle APQ equals angle PQC, and also angle AQP. Angle AQP equals angle CPQ. Here CPQ, angle AQP equals angle CPQ. Same reason you can give according to CPCT. According to CPCT, and these equal angles are the pairs of alternate angles. These equal angles are the pairs of alternate angles made by the transversal of which pair of lines? AP and QC. AP and QC, and also AQ and PC. AQ and PC. Therefore, you can say that AP parallel to CQ and AQ parallel to PC. Here you will get AP parallel to CQ and AQ parallel to BC. Here alternate angles made by the transversal of two lines are equal, means they must be parallel to each other. The lines are parallel to each other. Therefore, you can say that as AP parallel to QC and AQ parallel to PC, here you got APCQ is a parallelogram. Therefore, APCQ is a parallelogram. APCQ is a parallelogram. Here you proved that opposite sides AP parallel to QC and also opposite sides AQ and PC parallel to each other. So as opposite sides are parallel to each other, APQC is a parallelogram. So you proved all 5 here. Now the 10th question. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on diagonal BD. Show that first one, triangle APB is congruent to triangle CQD. Second one, AP equals CQ. Here it is given that ABCD is a parallelogram and AP and CQ are altitudes from the vertices A and C on diagonal BD. So let us write the given here. So write the solution. ABCD is a parallelogram. Given ABCD is a parallelogram. AP and CQ are perpendiculars. AP and CQ are perpendiculars. AP and CQ are perpendiculars from vertices A and C on diagonal BD. On diagonal BD. Here what you have to prove here? First one, we have to prove that triangle APB is congruent to triangle CQD. So you write, to prove triangle APB congruent to triangle CQD. You have to prove that triangle APB is congruent to triangle CQD. Here the triangle APB and here is triangle CQD. And we have to prove that they are congruent. So here write the equal parts to prove them they are equal. Here you know that opposite sides of a parallelogram are equal. Therefore, first you write the names of the triangle. In triangle APB and triangle CQD. In triangle APB and triangle CQD. First you write AB equals CD. AB equals CD. Why they are equal? You know that they are opposite sides of parallelogram ABCD. Opposite sides of parallelogram ABCD, opposite sides of parallelogram ABCD. And also here you know that as AP and CQ are altitudes, you can say that angle APB equals angle CQD, both are equals to 90 degree. Both are equals to 90 degree, that is given. As they are altitude, the angles must be 90 degree. And also you know that here DB is a diagonal and DB becomes the transversal of the lines DC parallel to AB. So you can write that angle ABP equals angle CDB or CDQ, right? Angle ABP equals angle CDQ. Angle ABP equals angle CDQ. The reason that they are the alternate angles here. Alternate angles made by the transversal which transversal, that is DB of AB parallel to transversal DB of AB parallel to CD. AB parallel to CD. Therefore, you can write here according to which postulate? Two angles on sides. Two angles and one sides. According to AAS congruence rule. You can write that triangle APB is congruent to triangle CQD. Triangle APB is congruent to triangle CQD. According to which congruence rule? According to AAS congruence rule. According to AAS congruence rule. And here the first one we got the proof, that is triangle APB is congruent to triangle CQD. Next we have to show that AP equals CQ. AP and CQ are the corresponding parts of the congruent triangle APB and triangle CQD. As we proved triangle APB is congruent to triangle CQD, the AP equals CQ according to CPCT. So you write second one, to prove AP equals CQ. AP equals CQ. We proved that triangle APB is congruent to triangle CQD. Triangle APB is congruent to triangle CQD. Therefore, you can write AP equals CQ according to CPCT. According to CPCT. In this way, you got the proof for first and second. Now the 11th question. In triangle ABC and triangle DEF, AB is equals to DE, AB is parallel to DE, BC equals EF and BC parallel to EF. Vertices A, B and C are joined to vertices D, E and F respectively. Show that quadrilateral ABED is a parallelogram, quadrilateral BEFC is a parallelogram. Now here you observe the figure. What is given? Here ABC is one triangle, DF is one triangle, and also it is given that AB equals DE and also AB parallel to DE, and BC equals EF and BC parallel to EF. And the vertices of triangle ABC are joined to the vertices of DF respectively. Means here A is joined to D and B is joined to E and C is joined to F. Here you got a quadrilateral ABED, ACFD and BCF, we have to prove that quadrilateral ABCD is a parallelogram and also quadrilateral BEFC is a parallelogram. Third one, what we have to prove? AD parallel to CF and AD equals CF. And fourth one, also we have to prove that quadrilateral ACFD is parallelogram. Quadrilateral ACFD is also parallelogram, that also we have to prove. And next we have to prove that AC equals DF. And sixth one, triangle ABC is congruent to triangle DEF. So let us start to prove one by one. First one, what you have to prove? Quadrilateral ABET is a parallelogram. First you take down what is given here. Given that, so write the solution. Given that what is given here, AB is parallel to DE. So what is given? Given that in triangle ABC and triangle DEF, given AB equals DE and AB parallel to DE and also BC equals EF and BC parallel to EF. This much is given here. Here AB equals DE and AB parallel to DE and also BC equals EF and BC parallel to EF. This much is given here. Now first one, what you have to prove? We have to prove that ABED is a quadrilateral. So first one, what you have to prove? You have to prove that ABED is a parallelogram. That you have to prove. To prove that, first here you take in the quadrilateral ABCD, first one, to prove that ABED is a parallelogram. ABED is a parallelogram. ABED is a parallelogram. So you write the first, AB equals DE and AB parallel to DE. That implies, that is given here. That is given. That implies ABED is a parallelogram. Here it is given that AB parallel to DE and also AB equals DE. And here AD and BE are the line joining the ends of the equal and parallel lines. So naturally AD also becomes equals to BE and also AD becomes parallel to BE. So if in a quadrilateral, if one pair of opposite sides are equal and parallel, then also the other pairs of equal and parallel. So you can write that ABED is parallelogram as one pair of opposite sides are equal and parallel. That implies ABED is a parallelogram. ABED is a parallelogram here, because in a quadrilateral, if a pair of opposite sides are equal and parallel, then it is a parallelogram, because we know that in a quadrilateral, or a quadrilateral is a parallelogram A quadrilateral is a parallelogram. Quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Equal and parallel. So you got that ABED is a parallelogram. Similarly, you can show that here the next one BCEF is also parallelogram. Next you take second one to prove that BEFC is a parallelogram. BEFC is a parallelogram. Now you write in the quadrilateral BEFC, in a quadrilateral BEFC, you write, you know that it is given that BC equals EF and also BC parallel to EF, that is given. Therefore you can say that, or this implies BEFC is a parallelogram. BEFC is a parallelogram. The same reason, because in a quadrilateral if a pair of opposite sides are equal and parallel, then it is a parallelogram. So quadrilateral in which a pair of opposite sides are equal and parallel. So quadrilateral becomes parallelogram if a pair of opposite sides are equal and parallel. So you can say that BFC is a parallelogram. Next one, what you have to prove? Third one, you have to show that AD parallel to CF, and also AD equals CF. That you have to show here. So to prove that, right? That is the third one. To prove that AD parallel to CF and AD equals CF. We prove that ABED is a parallelogram, therefore B must be parallel to AD and also BE equals to AD. And also we proved BEFC is a parallelogram, that B is parallel to CF and also BE is equals to CF. The same line is parallel to two lines. So you know that the two lines which are parallel to same line are parallel to each other, and also the things which are equals to the same thing are equal to one another. Therefore here, by taking that concept, you can say that AD is parallel to CF and AD is equals to CF. So you write, we proved that ABED is a parallelogram. ABED is a parallelogram. Therefore, you can write AD is parallel to BE and AD equals BE. Consider this is the first one. And also we proved that BEFC is a parallelogram. BEFC is a parallelogram. Therefore, you can write CF is parallel to BE and CF equals BE. CF equals BE. So, consider this is the second. So, from first and second, here you observe the same line BE is parallel to the lines AD and CF. Therefore, AD must be parallel to CF. Same line is parallel to two different lines AD and CF. So, AD must be parallel to CF. So, you write AD parallel to CF. And also the same line BE is equals to AD and CF. Therefore, AD must be equals to CF. AD must be equals to CF. You write AD must be equals to CF. Here things which are equals to the same thing are equal to one another, and also the line which is parallel to the lines which are parallel to the same line are parallel to each other. So you got the third one. Next, what you have to prove here? You have to prove that ACFD is a parallelogram. That is the fourth one. To prove ACFD is a parallelogram. ACFD is a parallelogram. Now to prove that in a quadrilateral ACFD, we proved that AD equals CF and AD parallel to CF. AD parallel to CF and AD equals CF we got. Therefore, you write in a quadrilateral ACFD, we proved that AD parallel to CF and AD equals CF. That is from third you proved here. Therefore, you can say that implies ACFD is a parallelogram. ACFD is a parallelogram. The reason you know a quadrilateral is a parallelogram. Same reason you can give quadrilateral is a parallelogram. Quadrilateral is a parallelogram if a pair of opposite sides are equal and parallel. So you got that ACFD is a parallelogram. And AC and DF are the opposite sides of the parallelogram ACDF. So they must be equal. So you prove you take. To prove the fifth one, AC equals DF. df. To prove AC equals df, you take AC equals df. You take that. We proved that ACFD is a parallelogram. ACFD is a parallelogram. ACFD is a parallelogram. Therefore, you can say that AC equals DF. You know that opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. So you got the fifth one also. Next, sixth one. What have to prove here? Sixth one, to prove that triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. So you write the names of the triangle. So you take in triangle ABC and triangle DEF. In triangle ABC and triangle DEF, and here it is given that AB is equals to DE. Right? AB is equals to DE. That is given. AB is equals to DE given, and BC is equals to EF is also given. BC is equals to EF, that is also given. Then you can say AC is equals to DF. Here it is proved. It is proved here. So you write AC is equals to DF. That is proved. Proved in fifth. Proved in fifth. So you can write that. Therefore, triangle ABC is congruent to triangle DEF according to which congruence rule? By SSS congruence rule. SSS congruence rule. So you got triangle ABC is congruent to triangle DEF. In this way, 6 things proved here. First one is we proved ABED is a parallelogram. Next, BEFC is a parallelogram. Next, AD parallel to CF. AD equals CF. And also, here we proved AC FD is a parallelogram. And next, we proved AC is equals to DF. AC is equals to DF. And also, we proved triangle ABC is congruent to triangle DEF. Now the question number 12. The question is ABCD is a trapezium in which AB parallel to CD and AD equals BC. Show that first one angle A equals angle B, second one angle C equals angle D, third triangle ABC congruent to triangle BAD, fourth one diagonal AC equals diagonal BD. Here you write the solution. Now write the given here. What is given? ABCD is a trapezium. Given ABCD is a trapezium. ABCD is a trapezium, and also it is given AB parallel to CD. You know that in trapezium one pair of opposite sides are parallel. So here AB parallel to CD, and also it is given AD equals BC. Here the non-parallel sides are equal, so it is an isosceles trapezium. And here let us have the construction. Here hint is given in the question, that is extend AB and draw line through C parallel to DA intersecting AB produced at E. Now let us extend AB and draw a line through C parallel to DA intersecting AB produced at E. Here AB is extended and the line is drawn through C, that is parallel to AD, and that line is intersecting AB at E, which is produced. Now we got a parallelogram ADCE. Now you write, now ADCE is a parallelogram. ADCE is a parallelogram. Why it is a parallelogram? Because here AD parallel to C, that is constructed, and also as AB parallel to DC, AE becomes parallel to DC. So you write, therefore here you write AD parallel to CE and AD equals C. AD equals C. But here you know that, but it is given that AD equals BC. AD equals BC, that is given. Therefore, as BC equals AD and also BC, AD is equals to CE, all these three are equal. AD, BC and CE are equal. So you got, therefore, AD equals BC equals CE. AD equals BC equals CE. And next here to prove first one. Here let us prove the first one. To prove the first one, up to this you got here. To prove first, that is to prove what we have to prove in the first, what is there? Angle A equals angle B we have to prove. Now you know that what is the sum of the angle DAE and angle E. They are the interior angles on the same side of the transversal AE. Also you can take, they are the adjacent angles of the parallelogram. Adjacent angles of the parallelogram are supplementary. Consecutive angles of parallelogram are supplementary. That also you take. Or if you consider AE is a transversal of the parallel line, AD parallel to CE, here angle DAE and angle C are the interior angles on the same side of the transversal AE. That also you can take here. Therefore you write, that is to prove angle A equals angle B. So here you the sum of angle A plus angle E equals angle A plus angle E equals 180 degree. You can give the reason, interior angles on the same side of the transversal AE or the consecutive angles of the parallelogram ADCE. So write interior angles on the same side of the transversal AE. Transversal AE. So here angle E equals, you can write 180 minus angle A. Angle E equals 180 minus angle A. Angle E equals 180 minus angle A. And you know that here angle B, that is the angle CBE equals angle E. Why? Because here you know that BC equals CE. Take as BC equals CE, as BC equals CE, you know that angle E and angle CBE are equal. Both of them are equals to 180 minus angle A. 180 minus angle A, because here angle E and angle CB are the angles opposite to equal sides. Consider this is the first, this is the second. Or you can take here from first and angles opposite to equal sides. Angles, both you can combine here, angles opposite to equal sides. Why they are equal? They are the angles opposite to equal sides. Why it is 180 minus angle A? That is from first, because angle E is 180 minus angle A. So you take angle ABC. You know that angle ABC equals 180 minus angle CB. There is a linear pair. Here this angle is 180 minus this angle. So there is a linear pair. Here linear pair. You can write that linear pair. Now here angle APC is equals to angle ABC is equals to 180 minus angle CBE, and that is angle ABC is equals to 180 minus angle CBE, means that is 180 minus angle A. If you consider this is the second, so you take from second. Here you know that angle CBE is equals to what? 180 minus angle A. So 180 you write 180 only, minus angle CBE means 180 minus angle A. So you write angle ABC equals 180 minus, open the bracket, 180 plus angle A. Therefore you can write angle ABC equals 180 cancels, angle A you will get. Angle A, that is nothing but, that is you write angle B equals angle A, which is also same as angle A equals angle B. You got the proof for the first. That is to prove second one. To prove angle C equals angle D. Angle C equals angle D. And here the sum of the angle A and angle D. Sum of the angle A and angle D is also equals to 180 degree, because here AD is a transversal of the parallel line AB parallel to DC, and they are the angles on the same side of the transversal. So you write they are the interior angles on the same side of the transversal. Angle A plus angle D equals 180 degree. Reason? Because interior angles on the same side of the transversal. Interior angles on the same side of the transversal AD. Same side of the transversal AD. So therefore you can write angle D equals 180 minus angle A. 180 minus angle A, and then you can write angle D equals 180 minus angle B, you can write. Consider this is the third here. It is proved here. That is proved. Also you can take here, that is proved. Right, proved in first. Here in first we proved that angle A equals angle B. Therefore, in the place of angle A, you can write angle B. So, you proved angle D equals 180 minus angle B. Angle D equals 180 minus angle B. And also, you know that angle B means angle ABC. Angle ABC plus angle C. Angle C means angle BCD equals 180 degree. The reason, you know, interior angles, because they are the interior angles on the same side of the transversal BC. Interior angles on the same side of the transversal BC. Interior angles on the same side of the transversal BC. Therefore, angle BCD equals 180 minus angle ABC. That is nothing but angle C equals 180 minus angle B. 180 minus angle B. In third, you got angle D equals 180 minus angle B. And in fourth, let us take, this is a fourth. In fourth, you got angle C equals 180 minus angle B. In here, RHS are equals. Therefore, you can write from third and fourth. From third and fourth, you can write the C and D are equal. C and D are equal. So, you write from third and fourth, angle C equals angle D. Angle C equals angle D. Next, to prove triangle ABC is congruent to triangle BAD, that is the third one. To prove triangle ABC congruent to triangle BAD. Triangle BAD. Now here you take the triangle ABC and triangle BAD. In triangle ABC and triangle BAD. In triangle ABC and triangle BAD. And you know that here angle A equals angle B, that is proved, and AD equals BC given, and AB equals AB common side here. So you write one by one. First one you write AB equals AB common side, that is common, and AD equals BC given. AD equals BC given, and angle A equals angle B, means you can write angle A means angle DAB equals angle B, that is angle B means here angle ABC. That is proved here. Proved in first. Here first proof is that prove that angle A equals angle B. Already it is proved. So you have proved in first. Then you can write that therefore triangle ABC is congruent to triangle BAD according to know that side angle side postulate, that is SAS postulate. SAS congruence rule. SAS congruence rule. In this way you got that triangle ABC is congruent to triangle BAD. Next, again we have to prove that diagonal AC equals diagonal DB. You know that AC and BD are the corresponding parts of the triangle ABC and triangle BAD, and you can write that AC is equals to BD according to CPCT. So you write fourth one, to prove diagonal AC equals diagonal BD So we have proved that triangle ABC is congruent to triangle BAD. Triangle ABC is congruent to triangle BAD. Here we have proved that triangle ABC is congruent to triangle BAD. Therefore, you can say that AC equals BD according to CPCT. Therefore, that is nothing but diagonal AC equals diagonal BD. Diagonal AC equals diagonal BD.